Our question is, find the exact value of cos theta and sin theta if tan theta is equal to minus 5 on 12, and 0 is less than or equal to theta, which is less than or equal to pi. Is theta unique? When I solve this kind of problem, I always find it's easiest to think in terms of an angle that's less than 90 degrees, so I can put it in a right-angled triangle. So I'm going to define a new angle with the same value of tan except positive, and I'll put that angle in a right-angled triangle. Consider an angle phi with 0 is less than or equal to phi, which is less than or equal to pi on 2. So pi on 2 is 90 degrees. And tan of phi is equal to 5 on 12. What I'll do is I'll put phi into a right-angled triangle. So here is a right-angled triangle. And I'll put phi here. Now tan is the opposite side over the adjacent side, so our right-angled triangle could have 5 here and 12 here. And then tan phi would be 5 on 12. By Pythagoras' theorem, the hypotenuse can be figured out this way. So by Pythagoras, the hypotenuse is the square root of 5 squared plus 12 squared, which when I use my calculator comes out to 13. Okay, so because of this picture, we can see that sin phi is opposite over hypotenuse, so 5 on 13, and cos phi is adjacent over hypotenuse, so 12 on 13. And so our real angle theta is going to have these two numbers, but possibly plus or minus depending on where the angle theta is in the unit circle. So to do this, I need to look at the sign, the plus or minus, of tan theta. So I find it easiest again to draw a unit circle. So there's the unit circle, there's the y-axis, and there's the x-axis. And I can write A, S, T, C to mean that all angles all sine, cos, and tan are positive in the first quadrant, sine is positive in the second, tan is positive in the third, and cos is positive in the fourth. Now the information I've been given is that theta is between 0 and pi, so theta is in this part of the unit circle. And I also know that tan theta is negative. So tan theta would be positive for angles in the first quadrant. So tan theta is negative in the second quadrant, and so theta is in the second quadrant. Thus, because theta is in the second quadrant, so theta is in quadrant 2, so sine theta is positive, and cos theta is negative. So sine theta is 5 on 13 and cos theta is minus 12 on 13. Now, we were supposed to find the exact values of sine theta and cos theta, which we have done. So that's the end of the first part. There's another part to this question which says, is theta unique? Well, that means is there only one value of theta between 0 and pi, which gives tan theta equals -5/12. So since we've shown that theta must be in the second quadrant, then yes, theta is unique. So since theta is between 0 and pi, theta is unique. And that answers our question.